Electricity and its effect, class 7, chapter 14, third part. Childrens, in the last video we have understand how the electric circuit diagram, these are made with the help of electric symbols. Now first the explore why are fuse devices used in an electric circuit. Fuse device, so this is used in an electric circuit. So this is only the fuse itself, this is the safety device, and this protect the electric short circuiting. Now the next topic is effects of electric current. Effects of electric current. Electric current has three effects. These are heating effect, magnetic effect, and chemical effect. Now first we do the heating effect. Now can you imagine what everyday life would be like without electricity? In a today's life we can't imagine life without electricity because most of our appliances run by electricity. The advantage of electricity is the ease with which it can be converted into heat energy, light energy, magnetic energy, and chemical energy, depending upon the way we use it in a particular device. Electricity can be converted into different form of energy like heat, light, and chemical energy. Now we will discuss about the heating effect and magnetic effect of electricity in this section. And the chemical effect you will study in the next class, in class 8. Now the heating effect of electric current. Children, at home we use electrical appliances like electric bulb, fluorescent tubes, electric heater, iron, electric toaster, electric ovens. Okay, in using these appliances, the electrical energy is consumed. You are plugging in, you are using switch for using these appliances. All these appliances produce heat when electric current passes through them, which means that electrical energy is being transformed into heat energy. Means when we touch these appliances they become very hot. To understand this, electrical energy is converted into heat energy. Let us perform the following experiment. Activity 2. Our aim is to show that electric current produces heat. For this activity, materials required: a 4.5 volt battery, long insulated copper wire, and a thermometer. Now, procedure or method. First of all, wind a copper wire around the bulb of the thermometer so that the spirals don't touch themselves and the ends of the wire is fairly long. Now connect the ends of the wire to the terminals of 4.5 volt battery. Now observation, after few minutes rise in temperature on the thermometer, this is observed. Now from this activity we conclude electric current that flows through the wire develops heat and which raises the temperature of the thermometer. Children, this is very simple activity. You can try at home. You are having thermometer or battery. You are using that for many instruments. Now, many electrical appliances like electric irons, electric cookers, toasters, hair dryers, electric ovens, and the immersion heaters and hot plates also, so that we use at our homes having a heating element. And the principle of changing electrical energy into heat energy with the passage of electric current is applied in all these appliances. Here children, you are seeing a pic of electrical appliances. Now activity 3. Activity 3 aim is to show that heat is produced by electric current that can make metal filament to glow. Now for this activity materials required: 2 nails stuck on the wooden board as shown in the pic, piece of nichrome wire, nichrome is a metal, connecting wires and with switch and battery. Now procedure: stick 2 nails in the wood, take a piece of nichrome wire and tie it between the nails. Connect the nichrome wire to a battery through a switch. Now switch on the circuit for about 1 minute and now switch off the current. Touch the wire after a few seconds. Now observation. We will see that nichrome filament glows and becomes red hot when the switch is on. When it is touched again after switching off the current, we will feel that it is warmer than it was before use and it cools gradually. Now conclusion, the flow of electric current heats up the nichrome filament and makes it glow. Children, this is again very simple activity. If you can try. Now, normally all heating appliances consist primarily of two parts. First is a resistance called filament, which is a coiled length of nichrome wire. The filament, this is made of nichrome wire. This wire has high resistivity and high melting point. The second property is the insulating base made of fire clay, mica, silica or asbestos, in which the filament is embedded. These materials are also able to withstand high temperature of the filament and are non-conductors of electricity. Now for your more information, some box insight information. Smart eco-friendly bulbs. The traditional light bulbs waste electricity as heat produced in these bulbs is wasteful. This can be reduced by using new alternatives such as compact fluorescent lamp CFLs, light emitting diodes LEDs. They use only 20% of the energy used by an ordinary light bulb to provide the same amount of light. Replacing conventional bulbs with CFLs would thus save a huge quantity of power. Less power consumed means lesser emission of carbon dioxide and other pollutant from coal-fired power plants. Now the topic is electric bulb. The electric bulb. The electric bulb consists of a coiled filament made of tungsten in an evacuated and sealed glass bulb filled with a mixture of argon and nitrogen gas at a low pressure. Modern filaments are made of tungsten, which last longer and gives white light. Means their life is more and they are producing white light. When electric current is passed through the filament, then it gets heated to such a high temperature that it starts glowing. The advantage of using tungsten filament is that it has a very high melting point and very high resistance. So tungsten is used. Now for your more information, inside box, nichrome, this is an alloy and this contains 60% nickel and 40% chromium. Nichrome means Ni for nickel and Ch for chromium. It resists oxidation even when red hot and its temperature can rise up to 900 degrees Celsius. Nichrome, this is used in the heater. Compact fluorescent lamp. Compact fluorescent lamp means CFLs have an average lifespan of 6 years and each bulb provides a saving of 80% in consumption of energy. That would mean a saving of 34 kg of carbon dioxide per lamp per year. These days, LED bulbs, these are also made. They save electricity even more than CFLs and they are free of mercury. Children, here you are seeing pic of CFL and LED bulbs. I think you are using these in your homes to save power or to save electricity.